Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So before we get started, let me quickly introduce myself to you all first so you can be aware of the person you're talking to. So my name is Neeraj Keria, and I've been working in this IT industry for more than 12 years now. So now let's get started. So the main agenda for today's session is we are going to discuss on the introduction to machine learning. Then we are going to discuss on what exactly is reinforcement learning. Then we are going to understand reinforcement learning by using a simple analogy. And then we are going to discuss on the reinforcement learning process, how exactly it works. Then we are going to discuss on the Counter-Strike example on how it is useful, how reinforcement learning is useful in the popular game for Counter-Strike. Then we are going to discuss on the component of reinforcement learning definitions. Then we are going to see the learning concepts, Markov decision process. We'll be having an understanding of how the Q learning works. So that's the agenda that we are going to cover as a part of this entire session today. Now, first of all, let's start with a discussion on machine learning. Now, we know that artificial intelligence and machine learning, they all are among few domains, right? So there are most, we can say the top trending skill set, especially since the last 4 years now. And we know that AI is going to create almost 2.3 million jobs by 2020, considering its main goal is to achieve machines to mimic human behavior, right? So because again, artificial intelligence is nothing more than how exactly we train any kid. For example, when we are training a kid, okay, how exactly an apple looks like, or how to differentiate between apple, orange, and cherries. And we have to first of all train the kid using the image by showcasing the kid the images and then labeling them and then and there are multiple methods through which we can train the kid. So that's why we have first of all the machine learning concepts, and then so machine learning is totally dependent on how much of data we are using for training the system. More data we use, more accurate the results are going to be. By combining whatever they have learned as a part of machine learning, then we can combine this with the algorithm to get the exact results out of it as a part of machine learning itself. And basically, there are three types of machine learning available that we have: supervised, unsupervised, and reinforcement learning. So when we say supervised learning, we simply train the system by giving a labeled data set. When you say labeled data set, for example, we are training the kid. Now, instead of just by showcasing these images here, we can label, okay, that this is apple, this is orange, and this is cherry. And then they can try to match the same pattern as a part of labeled data, correct? Same way when we are focusing on unsupervised learning, when we have trained the kid and now we are letting the kid perform the action on its own, right? So for example, when we have trained the kid, okay, how the addition works, now we can let the kid perform the addition on its own, especially when that is why we have unlabeled data set. So in unsupervised learning, we mostly work with the unlabeled data set. So we can simply showcase the images here. For example, let's say we are showcasing the images here, and now we give them images of banana, of guava, and again for other fruits, right? And then they can separate these three fruits from the other fruits as a part of even when we have the data sets unlabeled as a part of unsupervised learning method. And then we have reinforcement learning. So reinforcement learning is basically taking the input as a part of feedback, right? So basically, it's simply it's simply we can say a branch of machine learning that permits system to learn from the outcomes of its own decisions. For example, let's say we have trained the system that okay, when done, I can simply close the system by using Control X, right? And suppose if the system tried use running the command for Control X and Control X didn't work, instead of Control X, Control C worked, correct? So now a system can correct its entire structure accordingly. That means now this program does not work. Now it can go for the other variation as well. So based on the feedback, okay, suppose for example, whatever they have done is right or wrong, or suppose what is the output that has been generated. So based on based on the actions they are performing, we are allowing the system to learn from their own outcomes, right? So that means we have a continuous feedback taken into account as a part of reinforcement learning models. And that's why these are three main machine learning models that we use in the real-time use cases. All right. if we have to elaborate reinforcement learning, so reinforcement learning, as we have seen, it's basically a type of machine learning where an agent, or that means we can say a bot, learns to behave in an environment by performing actions and seeing the results. For example, now if the bot starts to move here, right? If the bot moves here, again, it sees a close line. That means whenever the bot observes a close line to, we can say, in front of that bot itself, then that bot is not going to go forward in the same direction ever, correct? So that's why it is simply self-correcting its entire course based on the feedback it is going to observe here. And that's why it is going to simply rectify its own course in order to reach, we can say, complete the entire goal itself. Let's understand it with a simple example of baby, right? Again, here we can take the example for a baby to understand how the reinforcement learning works. Now, let's say baby starts crawling and make it to the candy. Now, suppose now the baby start crawling here, and again, without facing any kind of hurdles, the baby reached the candy itself. And now, when the baby starts crawling but fails due to some hurdles in between, and the baby start crawling here, now there may be certain hurdles, they may be multiple twice in between, like this one, and now the baby cannot proceed further because of the presence of this entire hurdle, correct? Now the baby starts to, now the baby will simply take a pause for a while, and again, then the baby has to learn how to overcome this hurdle and then how to remove the hurdles in order to reach to the goal that we have been designed for. And that's why there are two main core components as a part of reinforcement learning. We have agent and then we have environment. So agent is basically the bot that is trying to automate the entire task, correct? Whereas bot, we can say environment is the factors that he have to take care of as a part of the learning process, right? Same way now we can also take the example for any automobile factory as well. For example, let's say we are at an automobile factory filled with robots. Now these robots help the factory workers by conveying the necessary parts required to the assembly car. Now these are different parts that are located in different locations within the factory in stations. And the parts can be chassis, wheels, dashboard, the music systems, the engine parts, and so on. And the factory master has prioritized the location where chassis is being installed as the highest priority, right? And then we can now, the location at which a robot is present at a particular instance is called state. And that is at least what we are going to discuss. So we are going to discuss on the components of states, actions, rewards as a part of the equation that we have to take care of when we are designing the reinforcement learning models. Now, based on the understanding for reinforcement learning, we can also apply it in a real world scenario for Counter-Strike. So for example, say now the RL agent, the player one, for example, we have a player one. The player one collects state from the environment. The main purpose of players are to collect the states, right? And then based on the states, the RL agent, as in the player takes an action, we can refer to the action as A naught, and then initially the action is random. And now the environment is now in a new state, and the players now get a reward from the environment, and the RL loops through the until the RL agent, that is a player, is dead or it reaches the entire destination itself. So based on the feedback received, or we can say feedback as in a reward, then the same reward again is taken into account. So, and that's why the entire agent will go into loop until unless the agent is dead or it reaches the destination itself by taking into the consideration of multiple inputs. Now, let's understand the basic concepts of reinforcement learning definitions one by one. So, first of all, we have the component of agent. So, agent is basically the RL. RL refers to reinforcement learning. So, agent refers to the algorithm that learns from the trial and error. So, basically, it has multiple inputs and can start learning one by one, right? And then we have environment. So, environment is a world through which the agent moves so that it can run the hit or try method. Action is all possible steps that the agent can take, and state is the current condition returned by the environment, so that that particular condition can be taken as a reward or as a feedback, and then it can be applied to modify the actions based on whatever it has been given. Then we have reward. So reward is basically an instant return from the environment to appraise the last action. We have policy defined by pi. So again, the approach that the agent uses to determine the next action based on the current state. And then we have value. So value is the expected long-term return with discount as opposed to the short-term reward. And then we have action value termed as Q. So these are the multiple abbreviations that we are also going to use. So to have a quick recap, now we have agent, environment, action, state, then we have reward, the appraisal from the last action, then we are going to have policy, then we are going to have value, the expected long-term return, and then we are going to have action as Q, similar to the value, except it takes an extra parameter and the current action to be A. Let's understand on the reinforcement learning concepts. So on a reward maximization theory states that an RL agent must be trained in such a way that he or she takes the best action so that reward is maximum, right? So with minimum number of steps required here, the reward should be maximum. That's exactly is how the entire structure is defined here in terms of reinforcement learning. For example, here we have agent, then we have the opponent, and then we have the reward. So that we have to take the necessary steps in order to get the maximum output of any given learning. And then we have the component of exploitation. It is basically about using the already known exploited information to heighten the rewards. That means going for what exactly works. And exploration is about exploring and capturing more information about environment, something which has not been tested yet, and then we can go for hidden trial method. Now let's also understand on the components of Markov's decision process. So basically we can say Markov's decision process is basically a mathematical approach, or we can say it's simply a process which is a discrete times, we can say time control process. It provides a mathematical framework for modeling decision. It simply provides a mathematical model to frame the model, we can say that the decision making process, in where we can use it for situations where outcomes are partly random and partly under the control of a decision maker. That exactly is what Markov decision is all about. So basically it's a discrete time control process, which is basically useful for providing a framework for creating the models in situations where outcomes are partly random and partly under the control of any decision maker. That exactly is what Markov decision process is all about. And these are the following parameters used to attain a solution. Like we have set of actions A, set of states, rewards, policies, and value. These are all the factors that we take into account when we are working on Markov decision process. Now let's understand quickly on the components of Q-learning. Now, when we are placing any agent in any of the rooms, for example, suppose we are talking about Counter-Strike, right? So when we are placing the agent as in player in any of the rooms here, like 0, 1, 2, 3, 4, the goal is to reach outside the building. That is room 5. Now, 5 rooms in a building connected by doors, and each room is numbered 0 through 4. And the outside building can be seen as a big room as 5. And doors 1 and 4, they lead into the building from room 5. That is from the outside. So there are only 2 entries available inside this given parameter. That is a door from room 1 and door from room 4. And let's represent this entire room on a graph and each room as a node. So we have second, we have third, we have fourth. Now this is the inverted copy. So we have second room, then we have third. So we can come back and forth from second and third. Then third is connected to room 1. Third is also connected to room 4. And the main goal is to reach room number 5. And for reaching through room number 5, we have to go through the door 1 and door 4, because these are only 2 exits to the outer world, or we can say to the room 5 itself. Now, next step is that door leads directly to the goal have a reward of 100. Because again, the door that leads to the goal, or we can say door number 1 and door number 4, they will have a reward 100. That means if the user exits from 2nd to 3, reward is 0. If the user exits 3 to 4, reward is 0. If the users come back from 4 to 3, again reward is going to be 0. Same way the rewards for any other rooms are going to be 0, except if the user exits from room number 1 to 5, then the reward is going to be 100. If the user has landed into 5, but again it has not returned, then the reward is also going to be 100. If the user has exited from room number 4 to 5, then also the reward is going to be 100, right? And that exactly is how we can attach the reward value as a part of the entire reward parameters. And the terminology in Q-learning includes the term states and action. So room, including room number 5, represents a complete state. So obviously, suppose if the user comes from room number 2 to 3, obviously the state is going to be changed. Same if from 3 to 1, 1 to 5, the states are going to be changed. And agent's movement from one room to the other is called an action, correct? And in the figure, the state is depicted as a node while the action is represented by the rows. That means if the user comes from 2 to 3, then the movement here will be termed as an action. And when it comes to 3, then the current state is 3, and the action has been what has been performed, correct? That means initial state was 2. Now state 2 has been changed to state 3 here. And from state 3, we have a possibility of going to state 2, again, state 3, or state, we can say state 1 or state 4. There are three possibilities. And from state 4, there are again three possible. Again, the user has gone from state 4 to state 5 as a part of Q-learning scenarios. And if we have to put this in a state diagram, then the insert reward values into reward table, then we can create the entire matrix here as an action as 0, 1, 2, 3, 4, 5, and then we have multiple states here. And the -1 in the table represents the null value, that means from 0 to 0. If we go to 0 to 1, again no value. That means if you go from 0 to 3 here, again no value, 0 to 4 no value, but again if you go for 0 to 5, because again we can't go there directly, that's why it is also having null value. But if you go from 1 to 5 only, then we are getting 100. If you go from 4 to 5, then we are getting 100, and if we remain in 5 itself, then only we are getting 100 as a part of null value. And when you say -1 here, because again, we know that 0, we cannot go from 0 to 1, 0 to 2 directly, right? That's why we have the value as -1. Because there's no way, there's no interconnection between 0 and 2. In order to go to room number 2 from 0, we have to first of all go to room number 4, then room number 3, and then so on. And that's how we had designed the entire matrix here. Now, next is we can add another matrix Q representing the memory of what the agent has learned through the experience. The rows of matrix Q represents the current state of the agent, whereas the columns represent the possible actions leading to the next state. And formula to calculate the Q matrix, we have Q, where we have state and action, R, state and action for the agent, and then we have gamma multiplied by max for the same other matrix Q, which is for next state and all the actions. And here the gamma parameter has a range of 0 to 1, where gamma is less than 0, and we can say a value between 0 and 1 itself. And if the gamma is close to 0, the agent will tend to consider only immediate rewards. Whereas if gamma value is closer to 1, the agent will consider future rewards with greater weight as a part of Q-learning model. And that's how, first of all, we have to set the entire gamma parameter and the environment rewards in matrix R. Then we can initialize matrix Q to 0, select a random initial state, set initial state is equal to current state, select one among all the possible actions for the current state, and using this possible action, we can consider going to the next state, where we can get the maximum Q value for this next state based on all possible actions. And then we have to find the computation by simply define the Q state action, R state action plus gamma multiplied by max for next state and all actions. And once all the steps are repeated, then we can achieve the goal state towards the end. Putting this up as a part of matrix here, we can see the first step is to set the value of learning parameter gamma as 0.8 and the initial state as room 1. And then we can initialize matrix Q as 0 matrix, where from room 1 we can either go to room 3 or we can go to room 5. And let's select room 5 here, and from room 5 we can calculate the maximum Q value for this next state based on all possible actions. It's like we have Q state action, then we have R state action plus gamma multiplied by max as a next state and all the actions defined. Gamma value is between 0 and 1 itself. And that's why for the next episode, we can start with a randomly chosen initial set, that is 3. And then from room 3, we can either go to room 1 or 2 or 4. And here we can select room 1. And from room 1, we can calculate the maximum Q value for the next state based on all possible actions, where we can define Q as state action, R state action, gamma for next state and all actions, where we can start by Q31 because we are starting from 3 itself, and then we're using the gamma value as 0.8 multiplied by all the possible values, the initial value from 1 to 3, and the gamma value from Q1, 1 to 5. And that's how we can get the entire matrix updated. R is simply the matrix that we are referring to. And again, as a part of the continuation here, we can again start with the next state for 5 as well, right? And then we can start from 1. And now in the next state, 1 now becomes the current state. And then we can repeat the inner loop of Q learning algorithm because state 1 is not the goal state, because state 5 is the goal state, right? So here we can, from room 1, we can either go to room 3 or 5, where we can select room 5, and from room 5 we can calculate the maximum Q value for this next state based on all possible actions, where we can define the Q starting point from 1 to 5, and then we can take the same gamma value to be 0.8 multiplied by 5 is to 1 from 5.1, then 5.4, and then from 5.5 as a part of getting the reward for 100. All right, so as we are done with the discussion on the topics here. All right, so thank you so much, guys. Take care. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to EduReka channel to learn more. Happy learning!